Okay, this is the quadratic formula, part 2. And what we've seen before is that we have, for solving quadratic equations with ax squared plus bx plus c equals 0, we've developed this formula which speeds up the solving of these quadratic equations. I'm going to show you a little twist on it. What if you have a quadratic equation that's actually not really a quadratic equation? It's kind of a strange looking equation, but you can see it has a certain resemblance to the quadratic equation up here. The only difference is instead of x squared, it's x to the fourth. And instead of just x, it's x squared. Other than that, it basically looks like a quadratic equation. And we can use the quadratic formula to solve this. The only difference is we're not solving for x, we are solving for x squared. So when we go ahead and we use a quadratic formula here, all is good. You just have to remember that you haven't solved for x. You've actually solved for x squared. So the rest of it you can see exactly the same. So that's the only little twist here. So I'm going to do an example of that and show you how this would look. So we'll just clear the screen here. Let's say I was going to solve something that looks like this. Say we had x to the fourth and then minus 3x squared plus 2 equals 0. So we go, yes, that has kind of a quadratic looking structure, but we are going to go ahead and figure out x squared. So I'm now going to, I better identify a, b, and c before I get ahead of myself. So a is 1, b is negative 3, c is positive 2. So we're going to go ahead with negative b, okay, so negative 3 plus or minus the square root of negative 3 squared, which of course becomes positive, minus 4 times a, which is 1, times c, which is 2. And all of this is over 2 times a, which is 2 times 1. Okay, so this becomes 3 plus or minus the square root of 9 minus 4 times 1 times 2, which is 8. Okay, so that's going to work out quite nicely because we're going to get the square root of 1. So we end up with 3 plus or minus the square root of 1, which is 1, all over 2. So our numbers would be 3 plus 1, or 4 divided by 2, which is 2. And the other number is 3 minus 1, which is 2, over 2, which is 1. Now that's great, but remember this is still just x squared. So what we now have to do is solve the following equations. We've got x squared is 2, and we've got x squared is 1. Well, we solve this by square rooting both sides. Okay, so we're going to do that over here, and of course that brings in plus or minus. So I now have x could be plus or minus the square root of 2. And over here, when I square root both sides, I'm going to get plus or minus, and that's just x equals the square root of 1 plus or minus, which is 1. So I end up actually with 4 solutions instead of just 2. And whenever you have an equation that has an x to the 4, a fourth degree equation, there's always the possibility you could have as many as 4 solutions. On the topic of solutions, I'm going to do another example here. What if you were trying to solve something that looks like this? So say this was just a good old quadratic, and we said to ourselves, great, let's go ahead and solve this thing. Okay, so we go, yep, all set to go. A is 3, B is 5, C is 4. So I go ahead, I go, yep, I can solve this for x. So I'm going to have negative b plus or minus the square root of b squared minus 4 times A times C all over 2 times A. Okay, so I carry on and I get negative 5 plus or minus the square root of, now this would be 25, minus 4 times 3 is 12, and 12 times 4 is 48. All over 6. Well, what's going to happen here is we're going to get the square root of a negative number. Okay, so let's just write the rest of it here. So we're going to end up with the square root of 23, sorry, negative 23, and that's a real problem here because we can't take the square root of a negative number, not if we're working with just real numbers. So the conclusion here is there are no solutions, no real solutions. Okay, so if you run into that, no big deal. You just go, oh, there's no solution. This is a quadratic equation where no real number will make the left side equal 0. And that's all there is to it. So I'm going to stop there, and we'll pick it up later on.